So now continuing on to find concavity and inflection points, I need to find the second derivative. So I'm going to use quotient rule. This is my high, this is my low. So low d high minus high d low, which is 2 times x squared plus 2 times 2x, square the bottom, and away we go. So now I need to simplify this second derivative. The first thing I see is I can factor out an x squared plus 2 from the numerator, from here and from here. So that will leave negative 2x times x squared plus 2. And then we have minus 4x times negative x squared plus 2, all over x squared plus 2 to the 4th. So now this x squared plus 2 will cancel with one of these in the denominator. So now I have the second derivative equals, let's simplify the numerator some more, negative 2x to the third minus 4x plus 4x to the third minus 8x, all over x squared plus 2 to the third. So now I can combine like terms, and I have 2x cubed minus 12x over x squared plus 2 cubed. And I can factor out a 2x, and that will leave x squared minus 6 all over x squared plus 2 cubed. So if I'm looking for where my second derivative equals 0, well, first, the denominator never equals 0 and is always positive. So I know that my derivative, second derivative, equals 0 when x equals 0 or plus or minus square root 6. So now we have these intervals that we can check to see where my second derivative is positive, negative, to determine concavity. So let's check. Now we're comparing our second derivative to our original function. Between 0 and square root 6, I can choose the number 1 and the number negative 1. So when I plug in positive 1, I get a positive times a negative, which is a negative, so it's decreasing. When I plug in negative 1, I get a negative times a negative, so it's a positive, so that's increasing. Oops, sorry, we're talking about concavity. So that's concave down, and this is concave up. So now a number greater than square root 6 could be square root of 9, which is 3. So then I can choose x equals negative 3 in this interval. So if I plug in positive 3, I get a positive multiplied by a positive, which is a positive, concave up. And if I plug in negative 3, I get a negative multiplied by a positive, which is a negative, concave down. So for part C, where is it concave up? C. F is concave up on negative square root 6 to 0 union square root 6 to infinity, justifying our reasoning because f double prime of x is greater than 0. Now we can do concave down. F is concave down on negative infinity to negative square root 6 union 0 to square root 6 because f double prime of x is less than 0. And then inflection points happen where your graph is changing from concave up to concave down. So that happens here, here, and here. So F has inflection points at x equals 0 and plus or minus square root 6 because f double prime of x changes signs at these values. So all of those included your reasoning being justified as to why those intervals or inflection points exist.